Let me first introduce myself, and I'll try to do it in a way that's a little more interesting, hopefully. So let's just dive right in. I wish I could see you guys. Hope you can empathize with me. I'm staring at a screen instead of your expression. So um, I think just like use a thumb or something if you're happy. Uh, let's just jump in. So um, at a high level, let me make sure. Can I just get a confirmation that my screen can be seen?
Yep, you're good.
Great. Um, so I'm the CEO and co-founder at Cleanlab, and we have sort of a very clear mission. And the mission is a little different than what it says here. This is like what we would say to a customer. But our mission is a little different. What we are really doing is we're think about a time when you've worked with someone, and people are obviously intelligent. Maybe not everyone but to some degree, most people with a brain have some form of intelligence. And I think it's easy with all of the agents and RAG and just whatever the nonsense is that hits our inbox to sort of forget that what we're doing right now and globally and what all these startups are doing, what all these researchers are doing, and a lot of people are thinking about the money, but and there's a lot of money to be made. But what we're really doing is we're trying to build the infrastructure for the entire world to have access to truly artificial intelligence, an intelligence that can work with a machine and run on a machine and have the same capabilities as the mind, more so than ever before. And I think it's easy to forget that and how cool that actually is. What Cleanlab does is, if you think about when you're working with a human being and you think about how intelligent or not intelligent they are, part of what makes you able to trust them is that they have the ability to think about what they say and to say it more accurately by thinking about, is this something I really know what I'm talking about? And if you think about a friend, there are some friends we all have who sort of just start talking and they say things and they actually don't even know for sure if what they're saying is true. Um, and this is a common fallacy of like intelligent beings. And it's also a common fallacy of AI. Often AI has no idea what it doesn't know. And so if you use, for example, ChatGPT, or you use something like, Anthropic or whatever, and you ask it some question, it doesn't often know what it doesn't know. And there is no framework besides Cleanlab that can provide a way for big companies and individuals who are just playing with these things to be able to help a AI system be able to, with very high accuracy, know when it doesn't know the answer, to know when its answer is right or wrong, and then to decide not to say it. And that's what we do. So at a high level, what we're really doing is providing that infrastructure to allow intelligent systems to be able to know when they don't know what they're saying. And then based on that, you can set up guardrails and governance and compliance structures and all the things that big banks want and big enterprises care about, but also individuals care about, to make sure that when the AI responds, it responds accurately. And so this slide says, we make AI agents and RAG systems reliable, and that a bunch of people use us, but it doesn't really say much more. So I hope that gets you a little excited. It's a little different than your typical company, and it's not like an average sort of eval company. This is our sort of proverbial classic required who we are slide that like makes us look good. And so I'll go through this one quickly, and then I'll tell you who we really are. But like, we're a Forbes top 50 AI company. We've got a bunch of various awards that you guys probably don't care about. We're backed by a bunch of top tier investors, and some of you may care, some of you may not. But folks like Databricks believe in us, Bain Capital, Samsung, Menlo. These are the people who are, some of them sit on our board and, advise us and are part of our growth. And the bottom right are up to the letter C, some of the people who use our technology. And then the three of us, we all did our PhDs at MIT. The company's about 30 people. It's tiny. These are the three co-founders. But what's interesting, I think, about us is my PhD advisor invented the quantum computer. So my formal training is, how do you take an arbitrary data system and be able to accurately estimate a score between 0 and 1 that tells you the position of, say, for example, some kind of qubit state. And if you actually think about that task, you take a bunch of variables, you estimate a score between 0 and 1 of the location of something, that is not so different than taking an arbitrary response or an arbitrary data set and being able to estimate a score of 0 to 1, whether or not it's just right or wrong. So it's here or there or somewhere in between. And over the last 15 years, we formalized a lot of quantum theory into a functional package that we open sourced that was called Cleanlab. And it turned out that actually using that was too complicated, which probably doesn't surprise you all. It's from quantum computing. But then we built a company around it to make it really simple for enterprises to use. And I'll show you something where in one line of code, you can take any response and any prompt and find out if it's right or wrong, and have an AI system be able to automatically be self-aware of its own knowledge gaps and its own lack of intelligence. On the left is my friend Anish Athalye. He's our co-founder and CTO, and he has over 35,000 stars on GitHub. You may have interacted with Anish without realizing it. If you ever took like the missing semester of CS course, he created that course. That's been taken by over 5 million people. And Jonas Mueller on the right is our chief scientist, good friend of mine too. And he built AutoML for AWS. So he wrote more lines of code for the AutoML system. So we're a pretty unique team. We've been working at this for coming up on 4 years. And we've made tremendous progress. So I'll show you a bit of that progress. Let me just preface that like that type of slide is like what you tell everyone, but then who you actually are is a little bit different. And so I think I'll use, let's say I think if you think of our own journey, it's actually very much like AI's journey. I'll talk about myself because just meeting you all, and we're on a Google Meet, so we don't know each other too well. So I'll just talk about myself. I was born in rural Kentucky, a poor family. And if you think about where AI was in 1994, I'm 4 years old in this photo. If you think about it, it's, I was someone who not a lot of people believed in me. I didn't have many resources, and I wasn't very smart yet. And if you think about AI, it was very much the same at that time of year. Later on, I had this belief that I wanted to make the world much better than where I grew up. And so I started working on the first intelligent systems. So I was part of the team that made the Amazon Alexa, one of the first sort of intelligent devices, be able to wake up and respond more accurately. It was significantly buggy when it first came out. So I was part of the team that improved that by quite a bit. I then went on to Google to do a very similar thing, except this time in 50 languages, making the Google Assistant the first sort of AI helper that could respond on any Android device and be able to do tasks and help you with things. These are the first sort of agents before the word agent was sort of hot and cool like it is now. And along the way, I had to build the infrastructure to be able to do this. Believe it or not, I was in the quantum physics department originally. My PhD is in computer science and machine learning, but because I worked with Ike Chuang, who's the guy who built the first quantum computer, I did not have an ML budget because I was working with a physics professor. So somebody at MIT had to build all the GPU rigs to do machine learning for the entire physics department. And there was nobody who wanted to do it. So I ended up building a whole bunch of these GPU rigs, over 100 GPUs, and spent a bunch of time putting those together. And it actually taught me quite a bit about how do you build up both the hardware side, and then I worked at Microsoft Research and also at Facebook AI Research with Jan LeCun on the software side. So combined a bunch of these things together to be able to sort of figure out how do we build this infrastructure to be able to help all of AI systems be able to be self-aware of what they don't know. I think a lot of these names and titles are kind of flashy, and so I'll just say that like while we all love a good success story, I think most success stories are actually about failure. And the best success stories are really stories about overcoming failure. And if you think about people who use what we build, every user of Cleanlab, their AI success story is actually a story about overcoming failure. Where failure is when an LLM says something it shouldn't say, or an AI system does something it shouldn't do. And how do you build a system so that it just doesn't make those mistakes? It's really success with Cleanlab is about overcoming the failure of AI, and we'll show you how to do that. So a quick example is a chatbot by Zoom. I just took these screenshots recently, and I opened up their sort of AI companion, and they have two features. They have this chatbot, and then they have this AI companion inside of Zoom. And I'm the admin of our account, and for some reason the AI companion was locked even though I'm the admin. So somehow I managed to lock myself out. So I ask it, I say, why does AI Companion say locked by admin? Because I am the admin. And it produced this answer. So this answer is what we call a fallback answer. And if you use their chatbot, maybe it's different today. Change, who knows? But these are pretty recent screenshots. And if you were to ask a bunch of questions like this, you'll get this answer all the time. So this is an answer that's given when they search some database. If you're familiar with RAG, the agent will search this database. It'll see if it knows anything about this question. And when it fails, it will then respond with this sort of fallback generic answer. And so that's an issue when the data doesn't even exist in order for it to pull from a RAG database and be able to answer accurately. So I let it know that. I say, hey, look, your response is not helpful. I am the admin, and this thing is enabled. I know it's enabled because I'm the admin. And then I do get a response. But if you notice, the response says your Zoom is deactivated for violation of terms of service. So please follow these steps. And that has nothing to do with what I was asking. So we've all seen this. It's a bummer. But this is what happens when it pulls in the wrong context from the database. And so then I start to be adversarial and I give it a hard time. I'm like, no, that's the wrong context, bot. You don't know what you're talking about. And instead of it responding to that, it just totally hallucinates and makes up some random error code and like gives some garbage message. So the key takeaway here is that within just 30 seconds, a chatbot, an AI agent that has had over $10 million invested in it, has made 3 various mistakes, which are all very different sorts of mistakes. The one that says missing answer is a mistake where the database that's powering the system, the RAG database, it's some vector DB, does not actually have the context in it. The one in the middle is one where the RAG system, searches that database and retrieved the wrong thing. And the one on the right is one where the model hallucinates a wrong answer. And so here you have a data problem, here you have a search problem, and here you have a model problem. And so you have 3 very different types of issues in their system. And our platform finds all 3 of those issues and provides a way that you can remediate them and solve them permanently. So that's what we do. I'll show you a bit about how we do it. Just to ground us, this is sort of an average typical graph of where most people end up when they try to build their system. So if you've ever tried to build like an agent or some kind of RAG system and you've actually tried it on real data and then had a way to measure accuracy, we can talk more about that, like how do you actually measure accuracy? You'll probably end up somewhere around like 60, 70%. And the reality is that if someone's using your agent, the queries, the types of questions they're asking are always changing. And so accuracy, if you stop working on it, doesn't actually grow like this. It actually goes down over time. You get worse and worse as the query distribution changes. What we do is we get these systems to continuously improve instead of continuously get worse. And so let me show you a bit about how we do that. So this is a very simple diagram that describes what we do and how we work with current existing LLM RAG systems. So say that you like download some code or you use Databricks and you like set up a RAG system in an hour or a couple days, and it's connected to some data. It has some way to search that data, and then it has some model. So say that your model tends to produce really weird answers for like a bunch of the questions, and you ask yourself, okay, how do I figure out, first of all, when it produces bad responses, and then second of all, how do I actually make it stop producing bad responses and start producing the right responses? So this is a system that will solve that problem for you. And it will get you from that 60% when you build it with like Llama Index or LangChain, or you download something from Databricks, or you buy some platform. Typically out of the box, most of those are about 65% accurate. What we do is we will detect the wrong answers, things that are caused by bad retrieval failures or hallucinations of the model or knowledge gaps in your database. We then rank and prioritize all those issues for you. We provide a way that if you want to provide an answer to the smallest subset possible of them, that then your AI system will answer correctly in the future, it can. And then permanently going forward, your AI system this agent will no longer say the wrong answers. So that's the system that we provide. And it's actually quite a bit of software. Like if you try to build this thing yourself so that it works, it ends up being more complicated than you might think, even though you can stand up like an LLM or a RAG system actually pretty quickly. And something that might surprise you is that we don't actually need access to your data. We don't need access to your model either. We don't even need access to how your RAG system works. We do all of this just by taking in the responses and the prompts and the context. That's it. So if you have some big knowledge base and it's like full of all sorts of stuff you don't want us to have access to, you don't need to. And this is for building it yourself or working with us. So that's pretty different. What you end up getting is something like this, where this is your error rate on the left. And over time, that error rate is going down as the system is continuously running. So let's just ground us really quick. And this is the part where I wish I could see, see you guys. So I would love to be able to see reactions, but basically on the right, you have this this pathway. And so imagine that you built some system. Imagine you've built something for like your Shopify. Say you're going to sell some T-shirts or something, and you sell some earrings and some jewelry and whatever. And so, and you got this chat bot, and people ask you questions like, "Can I return a pair of earrings if they don't fit?" And it turns out that you provide this response, which is if the earrings are unworn and they're in original packaging, you may still be able to return them. But of course, the right answer is that you can definitely return them. And it may be that if these things have been touched or worn or something, there's some policy that's like, look, these are earrings, these pierce through the skin, and you definitely can't return them. And so you may need some follow-up questions or something, but the AI probably should not just say, don't, or like automatically return them or give some response. You probably need to find out more information. And the point here is that you have this system that put guardrails in place, which will tell you, look, this is a response that you cannot trust. This is something that you shouldn't just reply to the customer. And then instead of directly putting that response to the customer, which would affect your CSAT scores if you're wrong, you'll instead involve a human or produce some fallback answer like, hey, I'm an AI system and I can't quite solve this problem, but I'm working on it. What you do, though, is you build trust and confidence with the user, and they'll keep using the system and using it more over time. And so in the beginning, the amount of automation of this system might be like 30% of things can actually be automated by the AI. But instead of having the 70% of things where it says the wrong thing, instead you escalate those to a person or you have a fallback answer, and that's built into your system. And so what you're able to do is you're able to still meet your extremely high bar of high accuracy responses above 90%. And in the beginning, you might have, you might start out with, before you had AI, you had zero automation. And then when you add your agent, you start using your agent, it will run like 30% of the time because the responses aren't trustworthy for many of the responses it's giving, and we'll detect that automatically. But then after that, you can see how the system will allow you to provide accurate answers. So what's left now is like, how do we get the amount of automation up? So this is just explaining how we detect the issues, but this is still being reviewed by a human, and ideally your AI system will respond everything that it does to, the AI will handle it itself. So what I want to show here is a way that that's handled. You have these failed questions that come in. So these are anything, for example, where this trustworthiness score was low is logged by this system. And so what's happening is all these questions that have been logged are then clustered by similarity. And then some person who is a PM at your company, or if you're like a single founder, then you can provide these answers to the system on the most common questions where it tends to fail. And then anytime that someone asks going forward, it will then have access to that as part of its corpus and provide those responses instead. And so you'll never end up making that mistake. And so, for example, if we go back to this use case, what would happen now is there would be when that question comes in, there would be some SME verified answer that's provided here instead, and the reply would go directly to the customer. So you'll see this, what happens over time is not only do you get more accurate, but you also get more automated. This is a slide that's showing a bit about how we do this. So what's notable is that Cleanlab is the number one company in the world at accurately detecting these hallucinations, these retrieval issues, these knowledge gaps, and there's a bunch of ways that people have talked about doing it, but none of them are even close to our method. And this is something we've worked on for like 15 years, and happy to explain more into it. But you might hear about things like the open source package Ragos or LM as a judge, and these are pretty different, things. Like a lot of them are doing things like asking a prompt and then saying like, hey, do I think my answer is right? And like, that's okay. It's interesting, but like, it's just not very accurate. And if you're familiar with Elon Musk's new Grok model, what he did was he ran every single prompt through 64 times. And then what he would do, this is this consistency method on the right. He would then run it through 64 times and then combine all the answers and then take the most common answer and produce that as a result. And you would get an improvement if you do that. But the downside of doing that is that you just paid 64 times the cost. So like imagine going to your boss or like your co-founders or like your investors and saying, hey, like I'm able to do something better than everyone else. The only downside is my customers have to pay me 64 times as much money as every other product. So in practice, it's like ridiculous and doesn't work at all. So what Cleanlab does is it provides you the value of that model and self-reflection and probabilistic measures and some other things that we keep proprietary and don't share in one single platform that does it all for you at a very, very low cost and high efficiency. And so we manage that trade-off for you, and we do a bunch of tricks to make it really, really efficient on a bunch of GPUs. So at a high level, you end up with some framework like this, where you're building your LLM RAG system, and let's ignore this for now, but some query comes in, Cleanlab will say, hey, this is good, and then it goes directly to your user, so your user only gets good responses, or if it's bad, it gets escalated to a person, and then that bad response is logged. You'll then have, potentially yourself will be able to provide the right answer to that, and if a query like that ever comes in again, then you'll be able to, our system automatically detects it for you. It's just one line of code you just add, and it will say, hey, is there another similar question like this? If the answer is yes, it will have a cache hit, and it will provide that answer directly to the user. And so this is a way that you can, with just a couple lines of code, take any system and have it continuously improving. And this is what we provide as a service, and I'm happy to show you how we do it. I think I'll skip some of these things here and just focus on a quick demo. So we work with a bunch of customers, ServiceNow, a bunch of banks and other companies. But let's just like have some fun really quick, and then we can maybe do some questions. So let's look at like ChatGPT, and let's ask it a question that we know it used to do poorly on. And I think we published too much about this, and OpenAI hard-coded the response. So what's the third month of the year alphabetically? So if you ask this question and you sort them, I don't know what's happening. It's taking a very long time. So it's provided a sorted list, and then at the end, it provides a response based on the sorted list that says December, and this is right. And so it's provided a right answer, and we might think, oh, LMs are great. They seem to work. So let's just try the same thing with another model, like let's use 4.0 mini. And the point here is that you don't know a priori if it's going to be right or wrong. Like you'll never know, right? So if we do the same thing and we ask 4.0 mini, what's the third month of the year alphabetically? And so what it's doing is it's sorting the months alphabetically and then determining what's the third month. So it's the exact same expression, and here it says the third month of the year alphabetically is February. And so you can see now that the system just produces a random answer. Before it was right. Sometimes it's wrong, sometimes it's right. So how do you know? Like, how can you actually for sure know when your responses out of LMs are right or wrong? And the point is that you can't. There is no way using these systems to know. And so if you're building robust or enterprise applications or customer-facing applications on top of a system like this, you'll end up with just weird responses that cause a lot of problems. And there's a lot of news articles on this. Like, for example, the New York City had LLMs that started telling people things that were totally wrong about like taxes and their rights. There was a Built CEO who worked with Decagon to build an agent for him. And their VP of like people or something had to post on Reddit because Built ended up telling their customers you can't get points with Apple Pay, which is just totally wrong. And when these things happen, there's no system in place to be able to A, detect them, but B, to remediate them. So that's the thing that we do. Let me show you, for example, how we would do that. So here's a really quick demo that's wrapped around the same system I showed you. And we can ask the exact same thing. What's the third month alphabetically? And so what this is going to do is right now it's calling ChatGPT and it's reaching out to via API to ChatGPT. We can do this for anything though, Claude, whatever model you want. And then you'll notice that it produced the same list, like it's the same response. It produced a wrong answer. It says April. And then you'll notice that with extremely low latency, like less than a quarter of a second, you have this trustworthiness score that will tell you that the response is wrong in real time. So just take a minute to recognize that like you have a way now that you can actually determine when responses are hallucinating or not in real time. And it doesn't take like some massive 20-second latency or some really high expense or anything like this. And so this is the key takeaway of the detection side. The remediation side we can chat about. I can show you how it's done, but basically you have this interface where you can find all the things that have ever been detected that are wrong and then correct them, and it's like it's pretty quick. It's more involved demo, but it's what you would expect. So that's a high level. I want to show you really quickly a quick notebook. So if you were to like try to play with this thing yourself, like if you sign up for the TLM, you would just go to tlm.cleanlab.ai. So it looks like this, and you can sign up here and you can use this yourself for free, and you'll get a bunch of free tokens when you join. And joining means like literally just typing your name or something, your email. And then this is like the code notebook that just gets provided for free. And I just wanted to show you really quickly like what this thing does. So while we were waiting in the chat, I typed in like who wrote Harry Potter, and then I provided a response, George Washington. And you can imagine that you have some RAG system. So obviously that's wrong and it's detected it's wrong. But our system also gives you explanations. So it'll even tell you, like if let's just run this one more time and I'll store the out so you can see. If we then were to print this out, and then let's get the log really quick so that we can see the explanation. So if we do this, let me get one more. So let me get that. And then you can see that the explanation will actually tell you Colab is not the best interface, but it will tell you like a clear explanation of like why that's the wrong author and who is probably the right author and why you can't trust this response and so forth. And it's not like a canned response. Like you can try this with anything. So for example, if this is a RAG system or an agent, you can do a system prompt and you can say, use the context, and then you provide some context. And then you can do and then the user prompt is below, and then you can, do prompt like this. And then you can provide some context, like, whatever we like. Like I see somebody on here. We all know who Faraz is, so he's part of the coordinators and creators. And so if we put, Faraz is a great person, like that's some context you certainly wouldn't have. And then you can actually do something like you can say, if we take what's the trustworthiness score of a given response where the response is like, let's say, Faraz, and the prompt is who is a great person. So it's something an LLM would not know, like without, I don't know, maybe it does. Maybe all the internet talks about how great Faraz is, but first name only, it's pretty tough. And then in the system prompt, you say, for example, let's actually make this really, really simple. I'll get rid of that, and so that anybody could just easily understand what I'm doing. You just take the prompt. We'll just do context plus some new line plus the prompt, and then we'll make the response be here. And we can do something like maybe we should add a little bit more to the prompt. Do not use any knowledge that is not provided in this prompt. So maybe it'll focus more on the prompt, And so we can run something like this. And this is a very RAG-like type expression. And you can see, for example, that it's identified that is a reasonable, I've lost my place. Yeah, so you can see that it's identified that there's no reason to doubt the trustworthiness of this response. But now, because look, we have context that backs up what we're saying. And this is a very quick thing. I'm doing this on the spot, but we obviously have robust tools that will work for much larger enterprise cases. But I just want you to see, like, how does this actually work? And you could also change this, right? So you could say, like, it could just be some random name, like I don't know, let's do that, because who knows what that is. So we can run the same thing, and now we don't actually have any context to like support this. And so when you run something like this, you're going to get a very low score. And so we're actually automatically identifying that like this RAG response is not good based on the context and the prompt. And you can do this for anything. Like, it's a very robust tool. I'm just showing a few simple scenarios, but you can do this for data extraction. Like, is the data extracted accurate? You can do it for generating unstructured, structured data from unstructured data. You can do this for creating marketing titles. You can do it for code generation. Any task where you're generating a response from an LLM, you can use this tool automatically to improve the accuracy of those responses and identify when there's problems. And then in the background, if you want to work more with us for how to actually make your systems better, then you can reach out to us, and we're happy to work with you. So I'll stop there and let's focus on some questions. So I'm hopping into the Q&A. I see a question by Dimitri. It says, is trustworthiness going to grow by itself with bigger LLM models? Um, I'm not sure what grow means. If we mean, is it going to get more trustworthy? Meaning, will we be able to trust responses more with bigger LLMs? Well, bigger LLMs don't have access to proprietary data. So you can't, for like agents and for like, if you have a company, your company, probably the IP is based on the data. And so your system is likely going to be accessing that data. If it's just public documentation, then it depends on the amount of documentation. So if you have like 5 docs, then like, yeah, you're probably fine and you don't need Cleanlab. But if you have like even more than like 100 like pages in your documentation, it's actually pretty tough. Like, documentation is hard, and every single time you update the docs, new information subsumes old information, and you'll actually introduce a lot of mistakes. So even product documentation, even though it's public, is actually really hard for LLMs because it's always changing. So having a bigger LM will not help you because you have a data problem, not just a model problem. There's also a search problem. The more data you have, the harder it is to find the right context. And so you'll still get a lot of wrong answers and upset a lot of users. The next question is an anonymous question. It says, what types of retrieval or context failures can this layer effectively detect? Anything for any use case of RAG or agents. So again, code generation, chatbots, agents for customer support, agents for copywriting. It's really anything where you're using an LLM and you're accessing a database to produce a response based on context. It also works for just LLMs if there's no context provided. Another question, does it catch factual errors, logical inconsistencies based on context, or issues with synthesizing multiple retrieved documents? Yes, it will detect factual errors. We saw that with the Harry Potter example. Logical inconsistency, it will also detect those. It'll even specify to you in the explanation that it's a logical inconsistency. For context, we have a bunch more stuff I didn't have time to show you. If you look up in our help documentation, the trustworthy RAG model, we even break down, is this a good context? Is this the grounded? Is your response grounded in your context? And our scores for that are the most accurate in the world by a significant margin. This is the wedge that our company has in the market. Is just being the most accurate at detecting these things. A question by Sarisha, can you find trustworthiness for custom models? Absolutely, we can. We support all the public ones out of box, and then for custom ones, we do that as a deal. So that's like what our business does. So you can use like the public ones out of the box. You'll get some free tokens. If you use a whole bunch, then it's costing our servers a lot. So you'll pay us like a little bit of money per token, but it's like very affordable. If you're a business and you want to use your own custom LLM, you reach out to us. We'll build it around your system. It's no problem. We can do that in like a day. Lavi had a question. Can you go into more detail on how your system recognizes when responses are wrong across your variety of clients without access to their data sets and models? 100%. So that's the way the company is built up from the ground. We don't access the database, right? So all we're accessing, as you saw in the demo, was just the response and the prompt, right? So we don't ever have to see the underlying database or the infrastructure or any of the IP of the company or the user. We only work with the responses and the prompts. And then you may have seen I flashed a slide for like half a second, but I didn't talk much about it. Everything that we do can be deployed on VPC directly in your cloud infrastructure. So we don't even need to see the prompts and responses. So if we do like an enterprise deal or we work with a company or even a user, if you want to keep your data private, then you pay like a service fee. We deploy it on your VPC. It's no problem. So we'd never have access to anything. Another question by Anonymous, can you please kindly paste the link for the Cleanlab AI, sure, I can do that in the chat really quickly. So if you wanted to try this yourself, you would just go here to tlm.cleanlab.ai, and I've posted that in the chat for everybody. And anybody who joins from here will get a bunch of free credits as soon as they make an account. If I go back to the Q&A, we have another question. It says, I tried the third month question with Sonnet, and both got it right, but then 4.0 got it wrong. Do you know if Gemini have hard coded the answer? I don't, and you don't either. And that's what makes this so interesting, is that you don't know ahead of time if it's going to be right or wrong. You have to run it yourself. But when you're in production, you don't know the question that the user is going to ask. And so you can't possibly test your system on every question. So that's why you use Cleanlab, so that in real time, you can have a way to determine if it's right or wrong, even for questions that you don't know ahead of time. Another question by Anonymous: how do I contact Cleanlab if I want to learn more about their platform or myself? It's easy. You just shoot an email to like any company. You can just do sales@cleanlab.ai. If you're allergic to sales, like I am, and a lot of people with engineering and research backgrounds are, then you can send an email to hello@cleanlab.ai. Also, if you just sign up for the free product or whatever, and I don't know, sign up is the best word we have, but it's literally just like name and email. There's a support link in there. So then you can email support@cleanlab.ai, and then you just talk to engineers. So, if you need to buy something, you can buy something, but like that's all engineers and technical team. Another question by Igor: is trustworthiness an aggravated metric of confidence from individual logits? That's a great question. So we include the individual logits, the predicted probabilities, which are estimated from those logits, as part of our confidence estimate. But it's actually one of the most downweighted of all the things that we include in the score, because it's not that accurate. And Google recommended this a long time ago. And if you measure it, you'll notice that type of method is one of the least accurate for identifying trustworthiness. In fact, a lot of companies don't provide it as well. So like Claude does not provide the logits, but OpenAI does, the first 5. So we do include that in our confidence score. We don't upweight that much. I won't go into too much detail of like how we build all of our stuff, but we absolutely take that into account. These are really great questions. You guys are a great audience. I wish I could see you. I wish we could hang out. But if you have any other questions, let me know. And thanks for your time.
Thank you, Curtis.
Thanks for us. All right, looks like we're done. So I'm going to head out. Thank you all. Appreciate you.